You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Cody Don Reader. Cody Reader is an educator, scientist, and YouTuber. His channel, Cody'sLab, has over 2 million subscribers and was started 11 years ago. He focuses on experiments and other projects. Cody studied geology at Westminster College and Utah State University. Most recently, he started the Chicken Hole Base, an experiment in building a self-sustainable simulation of a Mars base.
Cody Reader, welcome to the program.
Hey.
11 years on YouTube. 11 long years. What initially got you to upload a video?
So I competed in my school's talent show. I had a fire juggling act, and my grandma wanted to see it, but she couldn't come because she lived kind of far away. And my friend of mine that was in class with me was like, hey, let's just put it on YouTube and like send her a link. That's much smaller than like emailing a whole video. And so at lunch in my high school, we just went into the library and we got on one of the computers and set up a YouTube channel. Uploaded my video, and a couple of days later, it got copy striked because of the music that was involved. So I took it down. And then I just kind of, since I had the channel, I posted some other videos I had, things that I had filmed with my iPod. And I eventually re-uploaded the video of the fire juggling. I just, like with the copy strike, I just let that roll. And I guess the rest is history.
Do you still fire juggle?
I can still juggle.
I
Fireball somewhere.
I am nowhere near coordinated enough to do it. I've tried.
That video got age restricted for a long time because apparently that's dangerous, even though the balls are like made to be safe. But
well, it's YouTube. You know how you know.
Yeah.
I mean, you're no stranger to things that shouldn't be taken down can sometimes be taken down, and
the problem is you're dealing with a computer program essentially, the algorithm. And once it starts flagging you, it just keeps going. It's like everything that looks even a little bit like I'm using a gun in a video, and that's inciting violence. Like, no.
They need to put a human in the chain more than they do. The problem is that they have legal reasons that they kind of don't do stuff like that, because it's a different thing if you're a platform versus a publisher, and they have to skirt these lines and all this sort of stuff. So I kind of see their position on it, but the end result of it, if you're a science YouTuber, the end result is a lot of headaches, And
there's a lot of videos that they have to sift through. So
yeah.
I understand it. I don't like it, but
that's where I'm at. I understand it. I don't like it, but But my biggest problem really isn't that. My biggest problem is when public domain footage gets claimed by somebody. Because I usually don't appear on camera, although I am right now.
I always like the 5 seconds of static or silence that gets claimed.
or just some music company will use stock footage and then automatically claim it, even though it's open licensed and completely free to use. And I always win the disputes, because I don't really use anything that I don't have permission to use. But it's kind of a pain, because it's usually music companies that put some stock footage in a video, and they themselves don't have a human in the chain in order to keep from disputing it. But that's YouTube,
I still love the site.
I still love doing it. I guess my anniversary number now is what, 6? Yeah, 6 years. So
you've been doing it a while too.
As a matter of fact, it's this month. Yeah, so my 6th anniversary is this month, a little bit later. And I, admittedly, I had no intention whatsoever of. I thought I would get just a handful of views, and I did this video on Tabby Star KSC 8462852,
I remember
and
that.
yeah, and it ended up getting a lot of views, and I'm like, well, maybe I should make more videos, and I never stopped.
I think that's when I found your channel, actually.
Yeah, well, you know what it was? It was every video on that up to that point was pseudoscientific. It was, it is an alien megastructure and sort of sensationalist.
Right.
And I got annoyed. I was like, you know, because I was following the papers and everything else very closely, and which I still am. And I was like, well, I'm going to post an actual science video on it, and maybe somebody will buy a book or something like that because I'd written 2 books by at that point. Little did I know what was going to happen, and here I am. Now you got a new experiment going that I'm really enjoying because it's something, I've been into horticulture and gardening for many years, but I've never tried to grow algae. You are farming algae. What is your end game? Is that going to be a food source?
Well, yes, I would like to replace a significant portion of my diet, at least in theory, with the algae that I grow. So maybe like 20%, I think I've seen people been able to get away with. It's more efficient than your vascular plants that grow up out of the dirt. It's more efficient at converting sunlight into energy, so it makes sense to use algae. It's got other medicinal benefits. You can produce oil and fuel from it. I was actually thinking I could use it to make soap, the oils, and saponify them. And it is, you can pump the algae around. I want to put it into solar panels, type thing. The problem there is if I was on Mars, which is kind of what I'm thinking of, it's I'm preparing to go to Mars. And if you've got panels filled with algae, that's water, and that's going to freeze at night because Mars gets cold. So I need to either insulate them really well, or what I'm actually going for is to move the algae out of the panel at night when it's cold and there's no sunlight. It doesn't need the panel anyway. And I guess another way you could do it is to grow the algae indoors. But the problem there is now you're reducing the efficiency with the artificial lights. You're pulling in the power from the solar panels, you lose 80% of the power there, and then the light itself, you're losing a bit of energy. So it makes more sense to use the algae directly with the sun to get the most energy out of it.
Now, I think one of the big questions people are going to have about this is how do you make it delicious? In other words, what can you do with algae that makes it into a sort of palatable component of your diet?
Well, it's not bad to begin with. It's kind of got a grassy, nutty flavor. The different algae, of course, taste differently. The spirulina, which is another one I'm growing, as long as it's fresh, it actually is pretty much tasteless. So you can just mix it with something else. One idea I've had is to feed it to other things like insects, chickens, mushrooms, something else, and then those would be more tasty.
Now, feeding it, okay, using it as a chicken feed, is it a wide? I mean, can you sustain a chicken just on algae? Assuming you can get it to eat it, but can you sustain? I mean, does it have the nutritional value needed to serve as a chicken feed?
It's got all the amino acids. I've seen some research where they're replacing a significant portion of the chicken's diet, at least. So I don't see any reason why it wouldn't work.
I seem to remember, you might know something about this. There was a guy that developed a cycle involving, I believe, coffee grounds, where you could actually use coffee grounds and then recycle them as a medium. Oh no, you could. I think the next step was you could use them as a chicken feed, and then somehow after that you could use them again as a medium to grow mushrooms, and
Right.
then the whole thing can then be turned into fertilizer, which fertilizes the coffee again, and this cycle continues. So, a Japanese scientist, as I recall, years ago, devised that. So maybe there's something like that you could do with algae. Because say you're feeding a chicken, can you use the chicken droppings to back and
Why not?
fertilize the the algae? Now the other thing is, all right. So say this in a context of a Mars colony, okay, and you've got this sort of apparatus set up where you're growing algae. What do you do about the radiation? I mean, is there enough water there to actually shield the algae and keep it going, or is that going to be a problem with just the environment itself sterilizing it?
So plants in general can handle more radiation than we can. I was reading somewhere that there's like, to get the plants to actually mutate, they're hitting them with like 20 grays of radiation, and like a human can't handle 1 gray. But a lot of that's due to the fact that they don't live very long. They don't have time to develop the damage, and algae lives even less amount of time. The glass and the water are going to block most of the radiation. So the UV is actually probably the biggest problem, but that's easy to block with just a sheet of glass. And then the actual cosmic rays and stuff, those, I think I read somewhere that like 4 centimeters of water drops the radiation dose significantly. Of course, to stop everything, you need the equivalent of the Earth's atmosphere, but you get most of it knocked out with just a minimal amount of shield. And I think the rovers themselves have dosimeters on them, and found that a human could survive on Mars for years without too much trouble. And if a human could survive, then the plants probably have no trouble at all.
And that's interesting because, I mean, it's straightforward, I mean, that's a food source, and not that hard to do on Mars. Now, we live in an age where Elon's always talking about founding a Mars colony. Do you anticipate that you will relocate to Mars, become the first Martian YouTuber, and grow algae there?
That'd be cool. I don't anticipate that I will actually go to Mars, but maybe some of my inventions, maybe the seeds that I develop, strains of algae, ideas, would go to Mars. I think that's very likely. Also, I'm not thinking that humans should colonize Mars quite so rapidly as Elon is putting forth. Like the early 2030s, that's just too soon. We need to study the planet more. We need to send more robots. We need to get samples returned at the very minimum. Make sure that if there's life there, we've studied it before we contaminate it. Because there's loads of questions that we would like to answer that would not be answerable if we've contaminated the planet, and thus humans are just bags of bacteria. You open the airlock once, and that the bacteria that's floating in the air is going to blow around the planet. It's just there's a reason why they sterilize the rovers. If I could go to space like right now, I would choose an asteroid. Or maybe the moon, somewhere where my presence is not going to contaminate it, and there's still interesting stuff, mineral resources perhaps, which I think we'll talk about more later.
Yeah, let's get into that now. This idea of asteroid mining. Now, we are lucky in that asteroids are falling to this planet constantly, and we have a big pool of meteorites that we can use to sort of characterize the solar system's materials, to a degree anyway.
We got apples from all over.
Yep, exactly. So you can actually go and take a look at meteorite samples and know that there is something of value there. Now, in this case, you're doing just that with the Campo de Cielo meteorite that fell in Argentina and was ironic, one of the oldest known falls, actually, believe it or not. I think it was
it's like 1,000 years.
Yeah, the local people probably knew about it even earlier, and then the Spanish first recorded it in the 16th century. So there's like conquistadors looking at this metal laying out there, being shown, pieces of it, and that meteorite is still there, and there are many, many, many tons of this stuff. This was a huge iron meteorite that I believe formed some craters, as I recall, down there.
Yeah, I think about 20
Yeah,
craters.
I seem to remember they're sort of oblique. They're a rare type of crater, but I don't know how well preserved they are. Anyway, this meteorite, it contains obviously iron and nickel, but other elements. Now, so far, what have you found in that meteorite?
So I've not finished my video on it, but I'm trying to do a video where I'm extracting the precious metals. The meteorites, they contain the valuable minerals that the Earth is depleted in because they all sank to the Earth's core when the Earth formed. But that iron meteorite, that is a core of a planetoid. And so all the precious metals that sank to its core, well, they're right there. So we can easily access them. Unfortunately, that meteorite is actually fairly low in the precious metals, which I've just found out today. It's like a tenth as much as some of the others, but it's still a pretty good ore. Like if you had a body of rock on the Earth that had the amount of precious metals that it has, that would be a very valuable ore, and you'd be worth to go mine. What I'm doing is just kind of getting an idea of how hard it is to extract the metals, kind of see how much is there. And I really wanted to get an actual bead of metal. It's like, yeah, this came from an asteroid. It's the first material that was mined from an asteroid.
Well, I guess you would hold the record as the first person to mine an asteroid, even doing
Well,
it here on Earth.
I'm sure people have done analyses and stuff, but
I don't know if anybody ever actually went and tried to smelt something out of it, though. At least I haven't seen it in the literature, if someone had. But it's going to be important because, how are you going to do it to extract the metal? Are you just going to completely melt the meteorite first and try to differentiate stuff out? Or how are you going to try to do it? Because meteorites are notoriously hard to deal with, literally, because they're literally crystalline structured iron nickel, compounds and things that,
so what I'm doing is just vaporizing it with acid, just dissolving it in a strong mineral acid, hydrochloric, which dissolves the base metals, the iron, nickel, and cobalt. And the precious metals, which are more noble, they do not oxidize from just the chloride ions, so they stick around. And the theory is just eat away at the iron and leave the other metals behind. And what I've so far found is that it leaves behind a shiny glitter, like the little sparkles. And I actually sent some of them in to be x-rayed, and I got back that yes, indeed, they do contain some of the precious metals. I've got the peaks for the platinum and the iridium. It's mostly iron and nickel still, so thinking maybe that's just a contaminant. It's just I haven't gotten rid of all of it yet. Or maybe it's like little bits of like natural stainless steel that is resistant to the acid. I'm not entirely sure yet. But one thing that is interesting, like if that is the platinum that's in those little flakes, the precious metals, normally when you have the precious metals dissolved in a base metal, like you take a piece of platinum and dissolved it into some molten iron and then cooled it off and then dissolved it in acid, the platinum would come out as a black powder, very fine. It wouldn't be shiny at all because it's just so fine of particles. The little crystals that the precious metal forms when it's that diluted in the metal are like on the order of hundreds of atoms across, so they're nanometer scale. And so they don't reflect light like metal does. But I'm seeing flakes that are shiny and glittery. And I think what's happened is the iron nickel cooled over such a long period of time. You get those crystals, the iron crystals that you can get when you etch the asteroid, when you etch the meteorite. You get the large iron nickel crystals. Well, I guess it makes sense that the precious metals would also crystallize out into bigger crystals. So I think that was quite interesting thing
that is interesting. I didn't know. Well, it makes sense though that it would do that because, as you noted, those things cooled over a very long period of time, which is what creates that Wittgenstein pattern and that you see in some iron meteorites. They're actually ones that were exposed to heat later where it lost it, and some of them is just really coarse octahedrite ones that have crystalline structure, but it's huge, which I think Campo de Cielo is one of those. But it's interesting that, yeah, it would, because, the minerals also do it too. Yeah, within that sort of pattern, because you see this sort of, you know, mineral compounds in between the crystals, so they
Yeah,
align as
both
well.
sides.
Yeah. So I wonder if graphite does it, because I know that's present too in at least Canyon Diablo.
Yeah. Some of the flakes I'm seeing might be graphite. That's a
Yeah,
possibility.
and even diamond. I know that industrial grade diamonds have been detected in iron meteorites as well. So that really tells you something about the pressures involved in
Well,
whatever.
they were at the core of a planet.
Yeah, exactly. Now, how much do you think you're going to get? All right, so you get a bead of metal, and it's mostly platinum. Out of say 100-gram sample, how much do you think that's going to reduce down to?
Maybe 10 milligrams. It'll be a bead that's big enough to see, and like you drop it on a plate, you'll hear it clink. I'm not expecting anything huge, but that's the thing about the asteroid mining that I don't think people have really realized is you're not going and picking up like gold and platinum bricks. It's still pretty diffuse. A ton of the ore is still going to only yield you maybe a few ounces of precious metal. So you still got to go through a lot of material to get to the stuff that's worth bringing back. And that's kind of something I've been thinking about a lot lately is how do you go through like 20 tons of material a day to get enough material processed to make it worthwhile to do it on a space mission? And like I'm realizing it's not going to be something that's going to happen anytime soon. We're probably going to go after water and other volatiles first. And those are pretty valuable out in space, not so much down here on Earth. But before we're like making pop cans out of gold, drinking cans, because the gold's devalued so much because it's just so much of it, we're going to have a process we can do huge amounts of metal. And like I've been thinking of ways to do it. There's the Mond process, which uses carbon monoxide to dissolve the metals, the iron, the nickel, the cobalt, basically dissolve those away like I'm using the acid to do. And then the Mond process is really nice because if you then heat up the carbon monoxide after, you can actually separate out the other metals, the different boiling points of the different carbonyls that form, and also the different temperatures that they break down. So you can make carbonyl nickel, carbonyl iron, carbonyl cobalt, carbonyl manganese, and you get the pure metal powders, which then you can use for whatever 3D printing and stuff. The other problem with the carbonyl process is that, well, first of all, it's really toxic, but that's, you're out in space. Toxicity is probably not something you're worried about. You're probably using remote control anyway. But the pressures involved in order to get the reaction to go quickly is quite high, like 200 atmospheres of pressure. And it has to be in a container that is not going to dissolve. So stainless steel's out, so that's mostly nickel and iron. So you got to use like silver lined reaction vessels, and 200 atmospheres of pressure. So you can kind of like industrially it's going to work, but we need a pretty good sized industrial plant. Another thing that I've been thinking of is maybe like a liquid extraction, like use a metal that will not mix with the iron, but could mix with the platinum. So basically something like, I was thinking lithium might do it. I'm not entirely sure. There's a little bit of pressure, not as much as the carbonyl process, to keep the lithium liquid at the temperature that the iron melts at. And like bowl the lithium through, pull that off, distill the lithium, get your precious metals left over, and then throw out the iron and put more iron in. That would be nice, because then all you have to do is melt the metals and distill a little bit of other material. But it's kind of exciting. I'm not entirely sure how it's going to go. I'm excited to like play with it a little bit. After this video, which I'm just doing to demonstrate that it is possible, I'm thinking I might make some synthetic meteorite material, just like some iron, nickel, put it together along with the precious metals and just play around with some different processes to see what actually works.
Now, you've also, on your channel, you've done some experiments with mining here on Earth, actually,
Right.
literally mining. So how does it stack up to ores that are present where you were mining?
It's way more rich than what I was messing with. Like I was pretty happy to get a 5 milligram bead of gold out of a 5-gallon bucket of material.
Now, was that is that area previously used for mining gold? I mean, are there gold mines or silver mines and all that were actually profitable out there, or is it sort of just a poorer area that has a little bit, but industrial mining was never a thing? Now, I know that, well, like places like Nevada, you know, where it's a huge silver, you know, silver lode, or gold in California, but did that area, was that ever mined industrially?
Yeah, it's actually pretty close to the Kennecott copper mine, the Bingham copper mine. So there's a lot of copper. There's a fair bit of zinc and lead. So it's actually the base metals, which are the majority of the value that's in the ground. And the other metals are just associated with it. They, like the precious metals, dissolve into the sulfide minerals. And then you roast the sulfide minerals, you acquire a little bit of the precious metals as well.
It's kind of interesting to think about this stuff because here the big thing was lead mining. I'm in Missouri, and we had tons and tons of galena, you know, the lead ore, and we still do. We just I don't think it's really very profitable to mine it anymore. All the mines closed, but we have these huge chunks of silvery galena where it's very, very, very rich in lead. And I would imagine it's easy to smell that lead out of that. I've never tried it, but you know, with that concentration, but we don't really get that with meteorites. You know, you don't really see much, you know, lead or things like that. I guess it's probably present, but just not in the numbers here on Earth. What process caused that, you think? I don't know if I've ever thought about that.
So the iron, it dissolves other metals, and it's heavy, so it sinks, and the other metals follow it down to the core. So the siderophile elements, the iron-loving elements, those are the ones that follow the iron down to the core. So basically everything in the middle of the periodic table, the gold, the platinum, the tungsten, everything else. Lead is a chalcophile. It likes sulfur, so it follows the sulfur. And there is lead down in the core. In fact, I noticed on my X-ray readouts that there was lead. I also saw mercury and arsenic. Those are just associated with the iron because the iron also dissolves some iron sulfide and nickel sulfide, and those other metals follow the sulfur. In fact, the majority of the world's sulfur, the majority of the Earth's sulfur is down in the core as well. Like 90% of the sulfur is down there because the sulfur dissolves into the iron. And that's actually why when you're smelting iron ore, they don't use coal, because coal has got a lot of sulfur in it. They use coke. They heat up the coal, burn off the sulfur, and then use the carbon that's left over for processing the iron. Because if they had sulfur in it, the sulfur would end up in the iron, which would make the iron sulfides, which get in between the iron crystals and make it brittle and weak, which is why forging a meteorite doesn't work out so well, is because of the sulfur content. And that's actually something I noticed when I was dissolving the meteorite, is I could smell hydrogen sulfide coming off, because the sulfide minerals that were in the meteorite were reacting with the acid, forming the hydrogen sulfide. So
that's actually amazing to smell a chemical reaction off of a piece of an asteroid.
Yeah, it's actually a problem, because the carbonyl process, for one, is not going to like the sulfur. I've talked to some other chemists. I think the consensus is that it would just leave it behind, which is not too bad. But you're still going to have to process those sulfur-containing minerals. So one of the products you're going to get out of the asteroid, the sulfur, which is potentially useful.
Yeah, especially if you're gonna, start dealing with life, with algae farms and things like that. Now, okay, so barring Mars, and we're leaving Mars alone because we find microbes there, and it becomes a nature preserve for the Martian microbes, which would be astonishing in and of itself because that's alien life, or at least we hope it is. Earth has been sneezing on Mars for an awful long time, and vice versa.
Even if it's life that came from Earth to Mars, it'd be interesting because when did it happen? How diverged it?
Oh, it's that's probably my number one hope to see in my lifetime is a detection of microbial life in any of the candidates in the solar system where it might be. Just one instance is enough for me. I don't expect we'll ever hear from intelligent aliens or anything like that within my lifetime anyway, but
Yeah.
I think we got a good chance on the microbes, and that's enough for me. But the thing is that, almost everything that we're talking about here has some utility. So do you see even the iron and nickel? I mean, for construction purposes. So if we do start colonizing space and we start, wrangling up asteroids and taking them apart, do you envision what we would be able to do 100% mining operation, put everything from that asteroid into use?
I don't see why not. Think about it, the asteroids are made of the same materials that the Earth is made out of. So anything you can make from the Earth, you can make from an asteroid. So like I'm thinking the O'Neill cylinders, build those, maybe with the fibers, you can melt the different minerals and string them out and build the cables to hold things together, the steel for like hull plating, the volatiles for rocket fuel, and all of the lithophile elements and the rocks of the actual asteroid could be turned into dirt, the carbon for life.
So let me ask you this. If you pulverized a meteorite, could you grow something in it? I mean, is that something that you might be able to do?
So I haven't like grown it in like meteorite dirt, but I have used meteorite as a trace element fertilizer for algae to provide the iron and cobalt and silica and other things that the algae likes. So I gave it the nitrogen and phosphorus and of course water. And then for the trace minerals, I give it the meteorite dust, and the algae seem to eat it just fine.
Well, it's just the same old elements. I mean, there's nothing different.
Yeah.
I mean I admittedly, that's something after several decades of writing science fiction stories, I've never envisioned the idea of somebody farming algae in space off of the remains of an asteroid, and that's about the coolest thought I think I've come across in a long while. Now, what of the moon? Now we're dealing with a little bit bigger of a gravity well, but not a really huge one, but we're also dealing with a whole lot of resources with the moon, including water. Now, what do you envision for that? Do you think that might actually be even more viable than asteroid mining?
So the moon is really exciting because, we got that gravity well, which is there, but not super strong. You can still get away with it. You get off of the moon with pretty minimal energy requirements. You'd have like a railway or something like maglev. In theory, could get up to speed and just fly off, and no rockets required, really. The moon is depleted in the heavier metals, just like the Earth is, but the surface of the moon is very, very old, right? Once it cooled, it's basically the same surface. It's billions of years old. And the precious metals we have here on the Earth, the majority of them actually came from asteroids and meteors that have rained down on the planet since the crust formed. And so on the moon, all that material is concentrated on the very surface, like in the regolith. So all you'd have to do is scoop that up, and you're mining asteroids, you're just getting some moon dust in with it. So you're going to have ore that's basically as concentrated as you could have on Earth, just in the material that is loosely on the moon. You can just take a magnet across the surface of the moon and pick up iron pretty easily. You've also got the helium-3 that people are excited about, which by the way, is also should be present in asteroids and like the planet Mercury.
No reason there wouldn't be. Yeah, same
Yeah.
process.
One thing about the moon is those craters at the north and south pole. They're cold traps. So when a comet or an asteroid that contains water hits the moon, it vaporizes the water goes up. It basically gives the moon a very temporary atmosphere. And that water, most of it goes and flies off into space, but some of it gets caught down in cold traps and shady spots where it's very cold, where the water can like freeze to the ground. And so you could have accumulations of water ice. And one thing that it kind of excites me about that, the geologist in me is like, okay, that should be laid down in layers and they should be intermixed with like dust from impacts. We can date that, like get the tektites from the vaporized rock, that resets the potassium argon dating system. And so you're going to have ice and then like vaporized rock from impact and then ice, and it's going to be layered. You get a core of that. You get a record of all the impacts that have happened on the moon. And that's really exciting.
That's unreal. Well, it's like Antarctica, with an ice core. Exactly. You've got a record there. That you're right. That's going to be fascinating and probably fairly straightforward to do. You could probably do that robotically and do a sample return, right?
Yeah, I'm very interested in getting some core samples because those could go back billions of years, and it might also include water vapor that's come up off of the Earth. So there could be material from the Earth. We'd be able to maybe differentiate between the asteroid impacts and the background frost accumulation that's come from the Earth. So we can get like isotope data and maybe possibly even like a bacterium that managed to find its way out.
Well, you got to wonder. I mean, when you've got, Earth life is resilient, and when we were talking about grays of radiation, some of the bacteria can absorb radiation that's even worse than what you find in space. As a result of having evolved to dry out, apparently they also got just ridiculous radiation abilities to withstand radiation, to the point that the names of some of these bacteria evoke that, like gamma tolerans and thermococcus. I forget the rest of it. Yeah, so you've got these mysterious bacteria that have no problem with radiation whatsoever. So, what life, spores, things like that, might have made it to the moon? And again, if you've got a record of that, but let me ask you this: we have lunar meteorites here on Earth, that we find, chips of the moon that get blasted off in those same impacts. Could a large enough impact on Earth deposit material from Earth onto the moon? Meaning, could you, in principle, find an Earth rock from the Cretaceous Paleogene impact sitting on the moon?
Yeah. So when that asteroid came in, it blasted material up, and then the material actually went back out the way that the asteroid came in because of the atmosphere was rarefied. The asteroid had plowed it out, so the material would have shot back out, and it would have came out with enough velocity to enter Earth orbit, maybe even leave the Earth's gravity well entirely. And the moon's the closest thing, so it would pick up the most material.
Now, what about this? Now, to get a little bit more sci-fi and speculative and Fermi paradox stuff. Artifacts on the moon. The moon seems to be the best place to deposit an artifact if you're an alien civilization passing through and you say, well, let's put a piece of concrete on there in case somebody evolves on that nice planet next to it. Do you think that is a viable method of SETI right now, is to start searching the moon for any evidence of past visitations by aliens passing through maybe 1 billion years ago?
So assuming they came 1 billion years ago, I guess like if you had tractors sitting on the surface of the moon, like maybe they'd like started to mine it or had solar panels and radio dishes set up, most of that would be buried in dust by now, right? It'd be very well camouflaged. So it'd be hard to see from the orbit. But if you could look at it from the side, it'd be obvious, right? So if there is something on the moon, eventually we'll find it, but it's probably going to be from rovers and people walking around on the surface. I wouldn't be surprised to see something like that. The Fermi paradox states that we should be seeing life everywhere. So it makes sense that there would be advanced life that have come and visited us, or maybe even something from the Earth, maybe some really intelligent raptors that built a moon mission. I don't think it's likely, but I also would not be like super surprised to find it, right? That'd be really cool to find, because the technology and the information we could get off of any artifact would be amazing.
Well, let's go down this trail. Imagine what an alien civilization, say they just wanted to say hello, and they're gonna we're gonna put a plaque on the moon that's huge. We're gonna make it out of some material that will last for a very long period of time and be able to withstand the lunar gardening process and then all of the little micrometeorite impacts that are going to occur. What material do you think would be best for them to use? Just instead of concrete, something even better, that just says hello on it. And if you think about it, and here's where I'm going with this, if you think about it, it may actually be a very good way of doing SETI, is to put inexpensive, very durable objects on the moons next to worlds that are habitable. As you're passing through, you're like, well, there could be somebody here someday, so we're going to just put a piece of concrete that sends a message. And
the lunar monolith, and have a of Wikipedia and a crystal buried underneath of it. The problem with meteors, like hitting the moon and gardening it, as you said, there's no material that can survive being hit by a meteor. The velocities involved, chemistry just cannot hold together. So there's not going to be like a material that can take a strike and survive. It's going to wear away. So the best thing to do would be to bury it under a lot of materials to have thickness to protect it. So dirt. So just pile up the regolith. So have something big and metal that we would notice, like maybe on ground penetrating radar scans, and just bury it deep. Maybe have it under a mound of dirt. Maybe it was originally pyramid shaped, but the meteors like kind of worn it into a kind of a rounded hill, and that might still be a little bit weird, like something that wouldn't like immediately show up, but if you were like standing next to it, you're like, that looks like somebody piled stuff up. That it's possible, and that's probably about what we would be finding after a billion years. We would have to be mining the moon and actually on there and doing lots of work before we could find something like that.
But it's not unprecedented, because a lot of archaeology these days is done from the air and by satellite, because you're looking for something that isn't obvious when you're actually standing there on it, but if you're in orbit, you can see it underneath the ground to some degree.
Yeah, ground penetrating radar or something. Yeah.
And I mean, it has to be said too, the asteroid that killed the dinosaurs, the crater is buried, and while we have loads of evidence for it, it's long buried, and
you can't see it.
It's still there. Yeah. Yep. Now,
I was gonna like the first paradox. The fact that we see stars in the sky probably means that we are pretty much alone in our bubble of the universe. Like, we're one of the first civilizations, and it's probably the next civilization is like really far away, and we just haven't interacted with them. We probably won't interact with them for a while. One thing that I had a thought a while ago is, once we do see them, like when we see stars start disappearing in a distant galaxy as they're getting Dyson swarmed and converted into usable energy, once we see that, it's probably not going to be very long before they're actually here. Because if you're moving towards someone at near the speed of light, to them, you're going to look like you're sped up, because you're moving towards the light and everything gets compressed. So once we see stars in a distant galaxy, like a billion light years away, starting to get Dyson swarmed, they've already been traveling towards us for a billion years at probably near the speed of light. So they're probably pretty close at that point. So,
well, anything regarding this is a question of both space, but also time. And I think people neglect the time aspect. And in another way that's done is the idea that you would exist at the same time as another civilization in your galaxy. They may, the Milky Way, say, just to put a completely arbitrary number on it, say it spawns 5 civilizations during its period of habitability, and none of them exist at the same time, which means most of the time the galaxy probably is uninhabited, and that we're just a blip, and we don't really have any guarantee that we'll still be here in 1,000 years, or we might be here for 10 million or a trillion years. We don't know.
Like into the universe, essentially.
Yeah.
One thing is like the fact that we're here, that we were able to develop and stuff and like have a planet all to ourselves, probably means that there's no aliens around, because they would have used the resources and we would have never existed because we wouldn't have been able to. We wouldn't have had the resources to exist. So it's almost like any universe in which you are around in order to observe it, you're probably one of the first or alone or very remote.
Well, that's the core of the Fermi paradox. Where are they? And that's another aspect of the time thing, is that people are like, well, they're just too distant. But the thing is that if you last for millions of years, your civilization, and you start sending out, von Neumann type probes or something like that, self-replicating probes, you've got the entire galaxy covered in a few million years with your technology at significantly low sublight speeds. It's not that big. It's only 100,000 light years across. So no one seems to have done that, or we haven't seen any evidence of it. So I kind of agree with you. I think, yeah, I agree with you that that's probably just rare. Intelligence is rare, but I don't think life is rare. What's your take on the microbes and simple life? Do you think that that's probably ubiquitous, a natural result of this universe, or an organic chemistry, or do you think it's rare?
Yeah, sorry. The fact that it showed up on the Earth's fossil records so soon, like basically as soon as the Earth had a solid surface, like the first crystals from the first rocks that formed on the Earth, we can see the isotopic ratios are out of whack from what they would be if they just formed naturally. So it's like life happened immediately as soon as Earth could support life. And that just, either that's a really big coincidence, or it means that life is pretty easy for a planet to make. So,
and that, again, I mean, that tells you, and then we look out and we have Europa, Enceladus, Mars, Venus, and hints are everywhere that maybe there's something else going on. And if you had, imagine if every one of them had independent occurrences, we would be able to look at the universe and say, this is a microbial universe. They rule it, but they rule Earth, so it's not that far of a stretch. But intelligence,
Earth was almost entirely microbes for the first 3 billion years. We had microbes basically immediately as soon as the Earth was able to, and then for billions of years there was essentially nothing. And then all of a sudden there was an explosion in multicellular complex life. And maybe that explosion is rare,
It's hard to say. That's one of the great filters, is the prokaryotic to eukaryotic leap. Maybe that doesn't happen too often, but that still leaves a whole lot of life in the universe. Very, very simple life, but a whole lot of it. And that includes algae. Photosynthesizing algae is a simple organism, but look at how resilient it is. So
it'll last millions of years longer than us.
Yeah, it's not going anywhere till the sun bakes it. Now with algae though, and the algae specifically that you're working with, this stuff. I mean, even an asteroid couldn't kill that, right? I mean, it would survive anything, essentially, other than the sun.
You'd have to essentially melt the surface of the Earth to sterilize it before you'd actually kill everything.
Well, that's what's slated to happen as the luminosity of the sun increases. Eventually it will. But that's the only thing I've ever been able to identify that could actually cause the extinction of all life on Earth, is the sun. Everything else, something survives it. The microbes survive it anyway.
But if something does wipe us down to microbes, does it take another 3 billion years for us to recover?
It's a good question. It doesn't appear that that's ever happened here, but but it's still. But then again, we also have weird stuff like shadow biosphere ideas, where there might actually be multiple genesises of life. We just can't detect the other ones on the microbial scale. And that's still an open question as far as I know. Do you think that that's a non-starter, or maybe there might be a shadow biosphere here?
I think that they would have been outcompeted there might have been multiple genesises, and there might be new bacteria or things that spring up, but just this one type of life that is prevalent on Earth has just filled every niche and is keeping everything else from developing. But that's one of the reasons why Mars is so interesting, is because if there's another genesis of life that happened there, they wouldn't be outcompeted by the Earth until, of course, an astronaut goes and opens the airlock.
Yeah, well, I don't know that we're going to be able to prevent that, though, because with all of the private initiatives, most notably SpaceX, I don't know that they're worrying too much about sterilizing anything. And then it also has to be said, we sent Vikings and things like that weren't very well sterilized, so who knows?
Yeah.
But
better than a human.
better than a human. But remember, this same rule works both ways. If
Right.
life here stamps out any second or third genesis, or however many there may have been, if the first genesis always wins, then we're going to a planet that also had a first genesis, and it may
Right.
win. And we have these weird hints, like the labeled release experiment from the 70s, where
Right.
something happened. Do you think that
Those were
what's your thoughts on that, on the labeled release experiment?
I'm kind of annoyed that they mixed together the different isomers of the nutrients. It's like the D-glucose and the L-glucose, the different right-handed and left-handed isomers of the sugar. Here on the Earth, life can only use one isomer, and they mixed them together because they figured, well, let's just make sure that something reacts with this, so let's put both isomers down. Like, if they would have separated the isomers and they only got a response from one of them, that would be a much better evidence of life, because chemistry doesn't care what isomer it is. It's the same chemical. So a perchlorate would react with the L-glucose the same as it would with the D-glucose, but life might be different. So that's a data point that they could have gotten and they were planning on getting, but scrapped because it made the mission a little bit more expensive. And that's like, you just nullified all the results you could have gotten. So there's basically no point of doing it in the beginning anyway.
It has to be said that they sort of, the ambiguity of that is what caused the experiment to be a failure, ultimately, in having a reliable detection of life. But at the same time, man, that would be some weird life if it could survive on the surface of Mars. That would be something very, very alien to what we have here in our protected little bubble, because that Mars life on that surface would be super life.
Well, think about it like life on Earth wouldn't be able to survive, would thrive in the surface of Mars, but it could survive being blasted out of a geyser and then drifting through the wind and landing on the surface and then being dried out and desiccated, and then it would wake up when it gets the nutrients. So Mars could have life concentrated around some geyser somewhere, and it would still be all over the planet. It would just, it's growing near the geyser. It's not actually growing everywhere.
So dormancy becomes a major evolutionary factor for this type of life on Mars, perhaps. What is your view about the phosphine detection on Venus? Do you think that could just be geologic, or do you think?
I was skeptical on that from the beginning. Venus that's just very harsh conditions. I think they've decided that detection was not like they look again and they don't see it. So it was like just an accident that they saw it. Phosphine could be formed in some processes. Maybe something on Venus is doing something weird that doesn't happen on Earth. That's still interesting. I don't really see that as a confirmation of life unless they could follow up on it, which they haven't. So at least not that I know of.
Now, we have to take a break soon, but I wanted to ask you one last thing before we get into, when we come back, we'll get deeply into your plans for Chicken Hole Base. But
Okay.
Before we go now, okay, in regards to the solar system, if you had to put a number on it, and you had to put a candidate place, do you think Mars is number one, or do you think Europa or one of the others is probably the better place to look for life?
For
and it
life,
might just for microbial life. Say your algae, an
Europa.
analog, Europa, huh?
Yeah, like we've detected salts, which means that there's contact with the rock and there's geologic activity. And you got the close to Jupiter, so you got the tidal heating. Uh, Definitely Europa. If there's anywhere, it's going to be there.
And that's the one I think that we should probably be very, very careful when we go take a look at,
Yep.
because that's where contamination gets to be a real problem, and that explains the Arthur C. Clarke parts. The alien said, "Leave Europa alone," because there's something
We
there.
know that Earth life could colonize Europa. Earth life lives in the bottom of deep sea vents. We're pretty sure there's deep sea vents on Europa, so Earth life could contaminate Europa very easily. Mars, maybe not so much. It's pretty deserted, so Europa is definitely the one to sterilize everything that goes there.
And we have to take a break. We are joined with Cody Reeder of Cody'sLab, and we'll be back in a moment. And we're back with Cody Reeder. So once you get these precious metals mined off of the surface of an asteroid, how do you get them back to Earth so that we can make money?
All right, so I have some pieces of rhenium here. It's one of the platinum group metals. It's one of the densest metals, and also one of the metals with the highest melting point. I actually took one of these beads and hit it with the oxyacetylene torch. Thought it was hot as I could. And can you tell which one I did it to? You can't. Like, it didn't touch it at all. The melting point is up there near what tungsten has. And so if you took a bead of that and dropped it in the atmosphere from orbit, it's probably going to land on the ground as shiny as it was up in space. So I'm thinking like forge your metals into like a dish shape, like the same shape as the heat shield on a capsule, but just don't put anything behind it except for maybe like a little control gyroscopes or something, and then just drop it. Get it on the right trajectory so it's going to land over a desert, and it's the heat tolerance is enough that it would be able to reject that heat. It'd glow brightly like a light bulb filament, but it'd survive. Then it'd crash land in the desert, probably crumple up like a piece of tin foil, and then you just go pick it up, load it on the back of a truck, and haul it to a refinery or whatever.
Now, that's going to work for very, very hard metals, like rhenium. But also, iridium is also like this too, right? It has a very, very high melting point, and we don't have much iridium here. And in fact, the most famous source of iridium here is from the asteroid that killed the dinosaurs. It's the boundary line, what they used to call the KT boundary line. I think that's now been renamed.
Iridium's the most plentiful precious metal in the asteroid. It's just that it's the one that is so rare on Earth, right? That the fact you find the iridium is just so weird for Earth rocks that it had to come from somewhere that is not differentiated like the Earth has. But yeah, iridium, super high melting point. Osmium, super high melting point. Rhenium, all of those metals. Gold is actually one of the lower melting point metals. So if you're shipping back gold, you'd probably have to protect it. I still think if you got it thin enough, it could survive entry, but you'd probably clad it with something else to protect it. Maybe have your precious metals stacked together in sheets that the highest melting point first, and then back to the lower melting points. You wouldn't want to do it with osmium, because osmium, when it gets really hot, it starts to react with oxygen. So it would actually burn away. So even though osmium has the highest melting point of any element, you wouldn't want to do it with that one. But platinum would do good for that, because platinum, you can heat it up in the air and it never reacts with oxygen. So
yeah, that's interesting, because platinum also is very valuable, and that's the one that's coming onto the table first. It seems, last I heard anyway, it seems to be the one that might be the first profitable one to return from an asteroid. What's your view on that? Do you think that that's true, or do you think it's still just a step too far to start returning platinum from asteroids?
The most profitable one is probably going to be water to return first, and not returning to the Earth, but like maybe Earth orbit, or perhaps somewhere out in space that's using the rocket fuel. That's going to be first. The next one is probably you get platinum, you're going to get the other metals as well. So those are probably going to all happen about the same time. You might get iron first, because you just all you got to do is remove the sulfur from the iron, and then you could actually make things with it. Maybe some of the olivine and the other minerals that can be melted and formed into fibers that could be useful. So you might be looking at getting those before the actual precious metals. It's going to be interesting to see how it goes down.
That's an interesting one in itself, the mineral olivine, which is very, very common in meteorites, to the point that there are pallasites that are, matrices of olivine crystals inside nickel iron, which is really interesting because what asteroid formed that? And there's kind of a theory about that. And
it's also a mineral on Earth too. It's just we don't normally see it because it's so far down. It's kind of a denser material that the Earth's crust kind of floats over top of the peridotite, which is the olivine. So
now, what use is it? Now, what can we use these sort of silicate type materials, which are also common, even more common than iron, really, in the solar system? What do we use that for? These sort of silicates.
Well, that is what I actually would feed the algae, because they dissolve in water and they're high in the iron and the magnesium and other elements that the algae like. So that's actually better than the actual meteoritic metal, because the nickel is so good for algae. But I think you can melt the olivine, or maybe some other. I know, but I'm thinking of basalt fibers. Basalt is kind of a silicate mineral or rock with the silicate minerals in it, and you just melt that down and spin it like a fiberglass, and that makes a pretty strong fiber. That's probably very useful,
especially on the moon, which has lots and lots of volcanic,
lots of basalt. Yeah.
And Mars, for that matter. Mars has got it. Now, how about meaningful oxygen production from algae? Can you actually get enough of a concentration in space to create a self-sustainable oxygen biosphere? Or is it just too much to ask for that little algae?
That's actually what I'm planning on doing for Chicken Hole Base, is to use algae for a sizable chunk of the oxygen production. The algae actually takes the oxygen out of water. It actually splits the oxygen off of water, and it uses the hydrogen to make the carbohydrates for its food. And then the oxygen is just a waste product. And then you breathe out the oxygen, or in the oxygen, and then out carbon dioxide. And then the algae takes that, makes water again, and uses the carbon for producing the carbohydrates. So there's a cycle there. So as long as it's a closed loop, you don't lose too much, then you could do just fine. You just have your water as your oxygen source. And actually the total volume of algae that you need for a human to, if you spread it out enough and you get enough solar sunlight on it, the actual volume of water with the algae is not very much. It's like 200 gallons, I figured. And then that's very doable. That's a ton of water. Just 1 ton. Obviously, I'd like to go more than that to have a buffer, and that's another thing about being out in space, on an asteroid, is you don't have the pesky day-night cycle. So you could, you still need to give the algae a rest period, but you could just do it artificially and have it pumping in a loop continuously and have some algae exposed at all times, essentially.
Now, everybody should check out Cody's new video on asteroid mining here on Earth, and also farming algae, which is a fascinating experiment because, again, as a lover of plants, it's something I would love to do, but I'm too lazy to go through all the trouble. So I just watch your channel so I don't have to. Now, Cody, what is your long-term plan? And there will be a link in the description below to your channels. What is your long-term plan for Chicken Hole Base? What is the ultimate end for the experiment?
Well, the original idea was that I would kind of simulate living on Mars, as I've said. I got the idea when I went and visited a simulated Mars habitat down in Hanksville, Utah, the Mars Desert Research Station. I stayed there for a while. I wasn't actually doing a mission. I was just helping with the refit. I actually pounded in most of the T-poles for the tunnel walkways between the habitat and the observatory. But there was a lot of things that I didn't like about it. Like, it wasn't a sealed system. They used diesel generators to produce power. I think they use solar panels now, but like I grew up on an off-grid ranch, and we used diesel power for electricity. And it just bugged me to have a generator running at night because it's just burning fuel that didn't have to be burned, right? Like, we would run the generator for a little while, charge up the batteries, and then we had like the fridge, the other appliances. Everything would just shut off at night, right? Just went to low power mode at night, essentially. That reduced the amount of power we had to store considerably. But the research station, they just had everything running all the time, which I guess makes sense if you have like a nuclear reactor supplying the power, that you don't have to shut it down and conserve energy. But I grew up like, we need to conserve energy. We would run the large appliances, like my sister's hair dryer. We'd have to start the generator and have the generator running, and like time her using the hair dryer around when the generator would be running, right? And there's just lots of little things that I was like, I could do this better. And I also kind of wanted to have a sealed system. This was actually going back to my Cody's Mine series that I attempted to do, which got shut down on. I wanted to have like a underground survival shelter. Like, if there was a nuclear war, I don't think there will be one, but the possibility is still there. Like, if the Cobalt-60 bomb goes off, like in that one movie, I'm sure people, something that makes the Earth's surface uninhabitable, it's still possible that the kind of thing could happen. So I just always liked the idea of being immune to it, essentially. The worst radiation disaster is still going to be better than being on Mars anyway. So if I could build something that could survive Mars, I could survive pretty much anything that Earth could throw at us. So the Chicken Hole Base is a little bit more ambitious than my original plans were. And things are going a lot slower than I would like, but once I get this first greenhouse and set up, it's basically a smaller version of the whole system, and I'll bring people in, and it'll probably speed up quite a bit. I'm excited for it, and hope other people are as well.
So do you think that you'll be able to make it completely self-sustaining and self-contained, just doing it on your own without anyone else?
So my goal is to, at some point, be able to go a week without breathing any of the Earth's air. So be completely sealed off and be able to be self-sufficient for at least a week, hopefully longer. Years would be nice. But like, I'm still, like, if something goes wrong, I'll have like automatic vents that open, just so, because the Earth's atmosphere is there, it's breathable, may as well use it. Don't limit myself, don't trap myself inside of a plastic bubble. And yeah. I'll probably use some resources from the air.
Now, do you intend to like publish the results after doing all
that? Maybe I'll write an official paper at some point. I just, for now, it's just gonna be all the YouTube videos.
Now, in the process of this, you're obviously going to be inventing some stuff and breaking some ground and that sort of thing. And earlier you'd mentioned that that's what you were hoping might be useful out of this, is that people might make use of it in space. So are you patenting all this stuff and going that route?
Oh, that's just a a headache that I have not bothered with. I probably should if I find something really good. Yeah, patents are kind of expensive, so we'll see. There's going to be like a cost benefit analysis, but I'm not really at it to make a lot of money. So if I find something that helps mankind, I'm not really. I would hate for someone else to get the patent and like exploit it when it's my idea. That'd be bad. So I would like mostly get the patent to stop someone else from doing that.
That's really the biggest problem, because if you don't, someone else does. Now, other things that you can grow in addition to algae. What are your thoughts on growing mushrooms and other things, bigger plants, more intense plants in space? Because people are going to want tomatoes and fruit and things like that. And some things are probably not going to ever be on the table, but some things might be. What's your view on more complex life in space?
So I also like fruit, grains and stuff. It's all great. What I like about the mushrooms is they can turn the parts of those plants that you can't eat into things you can. It's like mushrooms can take the straw from rice and turn that into edible protein and usable fertilizer, right? So mushrooms are definitely going to be used to consume those inedible parts of the plant. You could also use insects to consume those inedible parts, but mushrooms are a little bit better at breaking things down. I think they don't have to. They can eat the cellulose and everything, and they can live inside of a bucket essentially. You don't have to like give them light or air. There's obviously problems with everything, but I think mushrooms are one of the simpler things to grow.
There's been some talk too of mushroom material being usable as a construction material. Any thoughts on that?
Yeah, you could do that. I think if you're on a planet, the construction materials, you'd probably want to use rock and things like that. That's a little bit more abundant instead of using your very valuable carbon sources for building materials. Which I guess on Mars isn't too big of a deal because you can just pull carbon out of the atmosphere. But you're still using up your resource, like minerals and nitrogen and stuff to produce the mushrooms. So you start building your house out of it, you're locking away most of your nutrients, which might not be too big of a deal. But I just think that like the air plastic, like turning carbon dioxide directly into plastics is kind of attractive because that's just something you can do and doesn't have to be a tax on your biosphere at all. And plastics are a wonder material. So that's kind of what I'm thinking the chicken hole is like, is making plastic from the air. A gag I was thinking of doing is like have I don't have the ability to make plastic from the air, at least not yet, but like have a magic box that does it, like have that technology solved and like have RoboCody pulling a tank out of it,
Poor RoboCody. He has to do all of the grunt work.
Yeah, he hasn't been the crowd favorite that I thought he would be. There's like a backstory to him and things, which I've kind of been like hinting at in the background, which might come out in the next couple of episodes. I'm kind of trying to get away from it though, since people don't really seem to appreciate it very much. So I'll just like kind of drop that portion, but I do want to like wrap things up and like finish the story first,
Or you could always go evil with him, and that he tries to subvert you, and it ends up being unclear whether RoboCody or Real Cody is hosting the show.
Maybe this is RoboCody here.
Yes, you never know. Now, how about water and dealing with water? Are you going to be recycling as best you can the water
Yeah.
usage, and how are you going to do it?
Like the system will be sealed, so the moisture will be contained within it. It's like a terrarium. So, I'll probably lose some to leaks and stuff. So I'll probably have some method of getting the water in. I would like to have like a rotating furnace, like boil the water out of dirt, which I think is something you might do on Mars. I've also been considering using desiccants to pull water out of the atmosphere and then roast the desiccant to extract the water from it. You could do that on Mars. It'd be harder, but Mars is essentially 100% humidity in places. There's not a lot of water, but the water that's there is, it falls as frost every morning, essentially, and you could collect that. So you probably wouldn't get very much that way, but if you're not using very much water, then if you get a quart a day, that might be plenty for you.
Now, strains of algae and developing ones that are better for space is something you're interested in. How do you do that? I mean, are you just like selectively breeding it like one would do with a tomato and just sort of trying to tailor it? And do you see that algae can be improved for being grown in space?
Well, it's going to adapt to any conditions you put it in. Like, you give it enough generations, eventually it's going to get better to whatever situation it's in. So if you're growing it in an environment which is similar to what it would be experiencing on the Mars habitat, then it would adapt to that conditions. I'm not really selectively breeding it. I would like to, but I don't really know how. But just the algae that survives and thrives best will outpopulate the stuff that doesn't. So it would just naturally develop over time. Algae doesn't mutate very quickly, but certainly it would. And also, like the other plants, the like the tomatoes, I could definitely breed those, actually intentionally. It's an enclosed environment. I could seal it off, keep the bees out of it for a while, and hand pollinate it. I have complete control. So that's one option.
That's actually an even more ideal way of doing that than what we do in the gardening world as far as breeding, because you basically have to cover the flower with a tea bag, essentially, to make sure that the bees and everything stay away from it if you want it to self-pollinate. But in an enclosed environment like that, you can do it perfectly. So you could actually create exact genetic strains of what would be presumably heirloom vegetables, and then keep them that way, because you have, as you said, 100% control over everything. And that's interesting, because that might be applicable in running greenhouses and things like that, wouldn't you think?
So one problem I had last year or the year before? Anyway, I just bought some plants from the store, and I brought them in to grow in the greenhouse just to show that the greenhouse could support life. One of the pepper plants, I think, brought in some aphids, and those were really hard to kill. I ended up having to kill everything in the greenhouse to get rid of the aphids. I pulled the dirt out and everything. And the new rule is no live plants. No live plants comes into the system, seeds only, and preferably seeds that have been dipped in bleach. I want to keep everything super clean. And I'm kind of excited to not have to deal with powdery mildew. Here, in town, I'm growing my cucumbers and stuff, powdery mildew just attacks them. And it just blows in on the air. And the only thing I can do is spray them with the milk and the antifungals. But if I was in an enclosed environment where the soil had been sterilized and the seeds were clean, and before I go in, I change my clothes, maybe I could prevent from getting the powdery mildew in there. Plus it's the 100 miles across the desert. Still, if it does get contaminated, it's enclosed, so it might actually be worse. But it's similar to Mars, I guess. And mitigating those types of disasters is something that I'll be forced to deal with.
Well, it's going to be very enlightening because, you can't foresee everything. And while we have done stuff with the International Space Station and the Space Shuttle regarding seeds, and Russia did some too with Mir, I think. As a matter of fact, there's a strain of tomato called Cosmonaut Volkov, which I think descends from some seeds that the Russians flew at one point, and it's now a common garden tomato. But and then there were NASA tomato seeds and all kinds of things. I don't know what care was taken to protect those seeds. Probably nothing in those days. But with the stuff they're growing on the ISS, is there anything useful there that from the experiments from the International Space Station that you might be able to put to use in at Chicken Hole Base and vice versa?
So I'm not growing in zero gravity. So it's kind of limited what I can pull off of what their research is, because the space station is a zero gravity research station. Chicken Hole is assuming there's gravity, at least a little bit, because in order for my system to work, I need the gravity-driven convection to, have the hot air rise and cool off in the radiators, and the water gets condensed and recycled. You could do that in zero gravity, but you'd have to use like mechanical fans to blow the air around. I want to try to minimize that kind of thing, or at least have them not be relied upon, because I know things break. Things break so much.
Oh yeah, and that's one of the biggest problems with space. I mean, if it breaks, you are limited in how you can fix it. You can't just go to the hardware store. And if with your end realization of Chicken Hole Base, I guess you're kind of be in that same boat, right? That you don't want to, bust out and go to the hardware store if you need a valve or something.
Yeah, it's like a 40-mile drive to the nearest store. So, and that's one thing that's been really slowing me down is I get there and I find out there's something I need, and then it's like a week before I can go back to it. So, like, I'll get there, find out that I can't do anything, and I have to leave. So I like get a half a day of work every week or two. It's slow going, but it is speeding up. I'm accumulating tools. I've got a toolbox on my truck now. I try to take them with me wherever I go, because people, you never know when someone's going to like break in. My car actually got broke into a little while ago. I wasn't keeping anything in there, at least the value that I thought would be worth breaking into stealing. There was just like a spare tire. They got the gas and the registration papers. It's like, why would you even want that? Anyway, I should have just left the car unlocked, but they tore the door handle off and they broke in. And like, I know if I have a bunch of stuff there and I'm not there, then, it's just something to attract people to it. Eventually I would like to be out there more permanently. Like right now I'm in my house in town, which I've been trying to like clean out and move my stuff. I've got some shipping containers I'm trying to like move stuff into. But you accumulate a lot of stuff when you live somewhere, and when you can't like take it with you and like store it because people might be wanting to take it, it really slows you down. So I'm working on it. I'll get there at some point.
How's the astronomy viewing out at Chicken Hole Base? What's the skies like?
Yeah, it's amazing. That right there is the number one reason I wanted to move out there, is the Bortle 1 skies. Pristine. Like I can see the Milky Way, I can see Andromeda. Like the Milky Way is casting shadows, like really diffuse shadows. That was cool. I can see the zodiac light, the triangle of light, the bright spot on the opposite side of the sun from the Earth. It's just an amazing view. I wish more people could see it.
I have seen the zodiacal light, and few things are that weird. Just this angle of dust in the solar system, all of a sudden it becomes visible, and very visible in my case. I was at a dark sky location, and just before dawn I saw it, and I was like, that's the zodiacal light. Or I think another term for it is Gegenschein.
Yeah. I saw it a while ago, and I'm like, looking at it and I'm like realizing what that is. Like, it's the dust particles in the plane of the solar system reflecting light back. It's like, oh my gosh. So it's like you know how the moon goes through its phases? Well, the full moon's like 14 times brighter than the half moon. I don't know the actual number is, but it's, because of the way the shadows happen. Well, the same thing happens for dust grains out in the disk of the solar system. So you've got a bright spot that happens about where the full moon would be. that's just so cool.
Yeah, that's what I saw too, and I was just like, that. It's amazing, and the thing is that I don't know what it is about the conditions, but it doesn't always happen. You're not always guaranteed to see this, just certain times. So there must be something about the juxtaposition and weird,
Right after a comet's come through.
Yeah. And then also meteor showers. I imagine it's a nice place to be for meteor showers too, especially in one of the Perseids or one of the more numerous ones. Because again, the darker the sky, the more you see, as far as meteors go. Now, you found a meteorite, didn't you?
Yeah. I actually have it in my pocket here. A little common chondrite.
I see the iron flecks.
Yeah, because of the mountain.
Yeah.
So I live out near the Bonneville Salt Flats. I have for my whole life. And I've gone out there. I've spent so many hours just on the flats and looking around for meteorites. And I found this one. I had given up for the day and I was heading back to my truck. I took a shortcut over some hills. And, there was some rocks kind of on the tops of the hills where the wind had abraded the dust. And not a lot of dark rocks, because most of the rocks there were like tufa and other things that are lake sediment. And there's this dark rock, and I just, with my meteorite stick, I'm like, stick it. No, it's stuck. It's like, oh my gosh, I actually found one. And like I immediately, as soon as seeing it, like the feel the weight of it, it's like, that's a meteorite. Like loads of rocks I think might be a meteorite, but then find this one, I was like, whoa, that is definitely a meteorite. And it made me realize that I was looking in the wrong place. Like the salt flats, that's not the place to look. Because the salt and the water, that destroys meteorites. The iron flakes, they rust, and just like rebar and concrete, it busts it apart. So a meteorite sitting on the salt isn't going to last very long. Maybe 10 years at most before it's just a dark spot in the rust, the salt, and then it gets covered by the salt. But since I was up higher, up above the water table, that's where I would find the meteorite. So
yeah, and in that situation, they can last for thousands of years. Now, does the example you found, is that like fusion crusted, and is there any indication that there might be more of them from the same fall out there?
Well, it's pretty rusted. Like there's some spots that the rust is like pulled it away. It is pretty smooth. I think that is the fusion crust. Could be an individual, could be more. But the thing is, in the area that it was found, like even if there was like a shower of meteors landing on the ground, most of them would have hit the salt flats, and the salt destroyed them. So you're only going to find the one that was up high that was able to survive.
That's interesting. There used to be a time about 100 years ago where no one in the scientific community, at least the consensus was that you would never find a meteorite. It's a waste of time because it'd be too
rocks fall from the sky.
Rocks fall from the sky. And then a guy named H.H. Neininger came along in the 1920s, and he was a self-taught meteoriticist, and he went out and actually looked and amassed one of the largest meteorite collections in the world at that time, and even had a museum, and identified just a huge amount of new falls, and simply because he went out and looked, So it shows how science sometimes, the consensus ends up wrong, and it gets revised, and it's a constant state of revision from the very start, which makes it fun. Now, do you still hunt for meteorites? Are you still looking?
Yeah, like the property out in Nevada, I've scoured it quite a bit. Like every time I've got time, like in the mornings when I'm on a morning walk to stay fit, I've always got my eyes on the ground. I haven't found any meteorites yet, but I have found an arrowhead, which is, I'm looking for meteorites, looking for dark rocks that are out of place. And a piece of obsidian is a dark rock. And, the rocks around there are volcanic, but there's not a lot of obsidian. It's like a puffed up. So the eruptions, it puffs up into pumice instead of being a solid mass. And so I see this shiny black rock, so I'll go over there and look at it. It doesn't do anything with the magnet, but I immediately recognize it as something that has been shaped by man. It's got that triangular kind of shape. It's like, oh, it's out of place because somebody brought it here.
It's amazing that when you're looking at Native American artifacts like that and you find them, that obsidian could be from Oregon materials here that are sometimes found in arrowheads are from the West Coast, thousands of miles away. And yet the trade routes, such as they were at the time, that material would get moved around, and it's sort of an interesting record in and of itself because it gives you some indication of what trade was like in prehistory here. And you never know.
It's crazy to think that there was somebody here that could be 14,000 years ago chasing down a mammoth.
Yeah.
Although the size of the arrowhead is probably a rabbit type thing, but
well, you find a very famous type of point called a Clovis point that dates from that period, and those were first found in New Mexico, and but they're found all over North America now, and those date from that period. Those would be at the end of the last ice age. That's what they were using to take down mammoths and mastodons and ground sloths and everything else that's now extinct. All right, Cody. Well, we are out of time, and everybody should check out Cody's channel, Cody'sLab. And what's the next series? Are you going to continue on with the algae farming, or are you going to go back to chicken oil base, or what's next?
Well, my next video is going to be the meteorite, getting the precious metals out just to demonstrate that it's there, and then kind of speculate on how to actually go about the mining. Then I plan on going back to chicken hole. Chicken hole's gonna be a recurring thing, and I've got like a bunch of like littler videos. I want to try to like increase my production. At one point, I was doing 3 videos a week, and looking back at that, I'm like, how did I do that? Obviously, at lower quality, but I would like to put some liquid oxygen in a cast iron pan and strike an arc with a welder in it and just see what happens. It's fun.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.